All right, that's perfect. I think we're going to start this. So everybody's hearing me fine? All right, perfect. So welcome everybody. Hope you're having a great conference so far. My name is Phil. I'm an Android developer from Montreal. Work for Mirego. You might know me because I'm the organizer of Droidcon Montreal, and I am officially a GDE since not that long ago. And today, what we're going to talk about is the touch system. First, quick show of hand. Who here has fingers? Okay, that's most of you. That's what I would have hoped. Because actually, using your finger is pretty much the main way to use your phone. Some people like to tell you that voice is the future, but still user will use their fingers to interact with their phone. And there are many things that you can do with the touch system in Android, but usually as developers, what we really know and what we use day to day is the good old click listener. So who here has used a click listener before? Yeah, that's most of you, that's pretty much. In fact, if you never use a click listener, I'm pretty sure your app wouldn't do much. So we know it's easy, you attach it to a view, some magic happens under the hood when the user puts his finger on the screen and lifts it up, and you get notified. But in fact, there is no black magic here. Google is not using any secret API to do this. It's something that we could replicate ourselves. So we have all the tools to be able to do whatever we want with the touch system. So just for educational purpose, we'll try to implement our own button using only the touch system. So the first thing you would ask yourself if you had to implement something with touch would be, where do I start? Where do I handle those touch events? Well, you have two places where you can use it. First of all, you have an untouched listener, which should feel familiar because that's pretty much the same thing as a click listener. You have a view, you attach the thing to a view, and then you get notified when touch events happen. In fact, the funny thing, the method is untouched, but it's receiving motion events, not even called a touch event. Don't know why, probably for genericity reason. So that's the first place where you can implement it. The second place is if you're writing your own custom views, what you can do is override a method that is called untouched event, and then you still receive a motion event, and then it will have a Boolean return value, which is, was I able to do anything with this touch? Now that we have pretty much where we could use it, what is a motion event? Motion event is a class that encapsulates the whole metadata about a touch event. There are two great pieces of information that you will want to use. The first is the action type, and the action is what you were doing with your finger at the time, which is usually putting it on the screen, which would be an action down, moving around, which would be an action move, or lifting your finger up, which would be an action up. So for example, a click is a down followed by an up. Simple as that. The other thing that you'll usually want is know where you are doing what you were doing. So there are a bunch of methods, but the most useful ones usually are get X and get Y, which will be the coordinates where you click your view. It's relative to the top left of your view. So you don't have to manage the whole screen. You only have to manage your custom view at a time. So going back to the button we were talking about, how would we implement a simple click without using a click listener? Well, here I'm writing custom view, so I will just override the untouched event method. I will call super, because you always have to call super, otherwise a very bad thing will happen to you and your user. And then we're just going to switch on the action types that we were using. So when we have our first action down, what's going to happen is that in this fake button, we'll just set it like a press state, something very simple. And then when we have an action up, what we're going to do is simply reset the state. We're going to take a look at our get X and get Y to make sure that when we lifted our finger off the screen, we were still on the button, and then we're going to do a toast. It's as simple as that. Still, it's more complicated than on-click listener, but it's not really that complicated. And that's pretty much all there is to it for a button. Pretty simple, right? So let's try to do something a bit more complicated. In fact, a lot more complicated, because we're going to talk about scrolling. I don't know if you ever look at the scroll view class. It's gigantic. It's like nearly 2,000 lines of codes. It's pretty big. It's pretty complicated. And it does a lot of stuff. So I think it's a good place to learn. So let's try just to implement a very, very small subset of what this class does. In fact, we already have most of what we need to implement this. We still have our action down and up, special emphasis on the move this time, and we're going to make good use of get X and get Y just to know where we're scrolling. So what's the concept behind a scroll view usually? The concept is pretty simple. Like you mark where you were on the scroll view at first, and then when you move your finger, you just see where you are right now, and then you scroll by this amount. So if I was at position 10, I'm at position 15, I have to scroll by 5 pixels. That, in fact, it's not really that complicated. So if we had to implement this, what it would look like would be same thing as always, on touch event, you're still calling super because then again, if you don't, bad things will happen to you. And in the action down, what you're going to do, mark the position where you should be starting. And in the action move, we'll just calculate the distance that we have to move and then scroll by this amount. And if you see this method that's called scroll by on the screen, this is not a method that you have to implement yourself. In fact, that's a method that all views on Android have. So all views are able to scroll their content. It's a built-in capability, and this is why the scroll view is using. This is what a bunch of other views are using. And what this method does, it will add offsets to make sure that touch events are handled correctly and the drawing code is handled correctly. So that would be a very simple way to scroll. The thing is that it's also kind of wrong, because the thing that's going to happen now, if you see, I guess if the video ran, I don't see it on my screen. The thing that happens is that if you have a button on the screen and you start scrolling from the button, nothing will work. The thing that's going to happen, in fact, is that the button will receive the click. It will try to set its state. It will try to do stuff, but the scroll view won't ever have a chance to scroll. And as you might imagine, that's not the way it should work. We know that if we use a scroll view, all the content will scroll wherever we click, wherever we scroll. So how does this work? Yet again, no magic there. There are APIs to help us. But first, a little theory, a little vocabulary to go on. We have to talk about what a gesture is for Android. So a gesture is what you would think it is, like a swipe is a gesture, a pinch to zoom would be a gesture, but in fact a click is also a gesture. In fact, for Android, a gesture is simply an action down, so putting your finger on the screen, any number of events, and then action up. So down, bunch of moves, up, that's a gesture. Why is it important? Because of another concept that's called the touch targets. So if you look at the source code of the view, the touch mechanism, what you're going to see is that there is a whole bunch of codes to try to determine which view should receive touch events, which view should receive a gesture. So the way it works is that when you put your finger on the screen in action down, Android will look at all the views that intersect with the place that you touched, and then it will ask each view in turn if they want to become the touch target and handle the whole gesture. So the theme here is try to find a view that can handle the gesture and then dispatch all the events to this view for the rest of the gesture. And it's very cool for two reasons for us developers. The first one is that it's very efficient. So as soon as you've found the view that should receive all the touch event for the gesture, Android will dispatch the touch event directly to this view. So there are no view traversing for each touch event, so more performance for you, you don't have to do anything. It's also cool because the thing that's going to happen is that the first view that can handle the gesture will handle it also. You don't have in other views to guard against this. The other views don't have to know about the other views. So everything is neatly compartmentalized. So that's pretty nice. So like I said before, Android has to know which view is able to become the touch target, and the way the view does it is very simple. Remember in the onTouch event method, we saw that we have a Boolean return time. So you might have seen this before, and you said, I don't know what it is, so I'll just put whatever and hope that it works. Well, you don't have to put whatever. When you return true, that means that you can do something with this gesture. If not, if you return false, you won't be notified ever again until the next gesture. So in onTouch event, return true if you can do something, return false if you can. So, and that's the reason also why our first scroll view didn't really work with the button, because the button decided to become the touch target. So it captured all the events for the whole gesture. So the scroll view was never able to scroll. But as you might imagine, it's supposed to work. So how do we do this? Well, there's another concept that is called touch interception. And you might have seen this before. It's a method that's called unintercept touch event. It has pretty much the same signature as the untouch event, but it has a very different behavior. So the concept here is that when you want to intercept the touch, it's a chance that the parent view has to see all the motion event flowing through the children before they see those themselves. So the point here is that you can steal the focus. You can steal the touch focus yourself, the touch target yourself if you want, and become the touch target for the remaining of the gesture. And this is what happens in a scroll view. So it's obviously something that only happens in view groups. So the scroll view will see a bunch, let's say, of action moves and say, I want to become the touch target, and then it's going to steal the whole gesture from the child view, and then the system will send an action cancel to the view that had the focus before. If you want to see it a bit more visually, let's say that I put my finger on the screen, I have a scroll view and a button, and the first thing that's going to happen is that the scroll view is going to try to intercept the touch event. But then it's going to say, yeah, an action down, I don't want to intercept this, there really is no point. So I won't do anything. But the button will receive it and say, yes, I know what an action down is, I want to do this because that's the first step towards a click. So the button will become the touch target at this point, and the other events won't go to the untouched event of the scroll view, so the button is the touch target. Afterwards, what's going to happen is that the user moves his finger very far on the screen, so we can be pretty sure that it's a scrolling that was happening. So the scroll view will receive the move in its unintercept touch event method and say, okay, I can do something with this. I want to intercept it. So the scroll view will become the touch target. An action cancel will be sent to the button so that it can restore its state and be notified that it is not the touch target anymore. And afterwards, all the touch event will go directly to the scroll view. So if I have another move, it goes directly to its untouched event method until the end of the gesture. And that's pretty much it. So in our scroll view, if we had to implement this code, a very naive way to go about it would be to say, okay, let's say every time I get an action move, I want to intercept the whole gesture. So I'll just take a look at the event, action move, okay, I handle it. And that's pretty much it. And technically, stuff should work. But there are other problems with this approach. For now, the problem is that our buttons won't have its state restore. And why is that? Well, maybe because we haven't implemented everything yet. Like we said before, if the button was a touch target before, it had the focus, but now it doesn't have anymore. And we only restore the state in the action up, but it won't ever receive an action up. Now what we have to implement is the action cancel so that the button knows what it can do when its focus is stolen. And usually you really have to implement this because usually you have different behaviors if you're canceled or if it only ends. For example, on a button, if it cancels or it ends, you of course have to restore your state. So you were pressed, you're not pressed anymore. But in the case of a real click, probably you're invoking a click listener or something like this. But in case of a cancel, you don't want to invoke a click listener because the gesture was canceled. So usually you have to implement both, but sometimes if your view is simple, you can just do a falter in your switch statement and it will work. Like doing cancel and up do exactly the same thing. All right, so another problem that we have with this is that we are very aggressive with how we're going to intercept thing, because we say that if we just do a move the first time, we're going to intercept the whole gesture. And actually that's not the case, because we would like to think that our finger are very precise. So you want to click somewhere, it's really just an action down and an action up. But in fact, our finger are a bit sloppy usually, and the digitizer on your phone is very precise. So what a click usually is you put your finger so you have an action down, but then there's always a bit of wiggle room. So a couple of action moves will happen, and not by that much, maybe by 4 or 5 pixels, something very small, but it's still an action move, it's still moved. And it's a concept that's true everywhere. So what Android did was provide us with a simple mechanism to account for this. And there's a class that's called view configuration that you can use, which will give you platform-specific constants to be able to work with this kind of thing. So for every device, the amount of pixels would be a little bit different. It's based on the screen size, the density, stuff like this. So what you can do is just go get your view configuration, get what is called a touch slop, and you're going to have the distance that your finger is allowed to move before you consider it's a scroll. So let's say that for any given device it's 40 pixel. If you are under 40 pixel of moving, it's not a scroll. It's probably just the user moving his finger a little bit. And while we're on the subject of view configuration, it's a very good class to take a look at if you're implementing any kind of behavior with regards to touch. So it might be constants about how much time should you take before you consider a click is a long click. What should be the time between two clicks before it's considered like a double tap. Constant like this. Or what's the minimum velocity you should be scrolling before you consider the fling could happen. There's stuff like this. You're pretty much better using the view configuration class because it will give you behavior that is very consistent with the rest of the OS, and it will feel natural to the user. They won't feel like they're using a custom view, in fact. So if we were just to take a look at the touch slop, how we would implement this, it's still pretty simple. So let's just say that we took the constant for the view configuration. If we want to know in our view, in our scroll view, how to implement it, in our intercept touch event, at the first time we put our finger on the screen, we would mark this position. And then each time we move our finger, we would just check if the new position is bigger than the first position that we register in the action down. And if we move by this amount, we can be pretty sure that the user wanted to scroll, so we can steal the gesture. All right, so another thing that would be cool to have in our scroll view would be fling. So for now, our scroll view, it moves. It's nice. The button has all its behavior it should have. It cancels resource state correctly. But now, how about we have something cooler? So we'll add flinging. But flinging might seem a little bit daunting because we're not only directly manipulating a view right now, we have to enter the realm of velocity, of physics, something like this. So when you lift up your finger, you have to take into account how should the view decelerate? How do we keep it natural? Well, as usual, a couple of classes in Android that will allow us not to do this much math. The first one that you might encounter that you might like is called the velocity tracker. The velocity tracker is actually a pretty interesting class that is nothing more than a math engine, in fact. The way it works is that you're just going to add motion events to it every time you encounter one. And when you have to do something with this, you just say, all right, compute the current velocity, and it will give you the velocity in X and Y in pixel per millisecond or pixel per second, depending on the method that you use. So using this, you can say, all right, I was flinging, and now I'm going at 100 pixels per second. That's cool. You already have speed, so you can think of the best way to animate everything. But then again, if you want to animate everything, you have to be pretty good at math. You have to think about friction. You have to think about viscosity. It's still hard to think, even though you have the basic building block. But yeah. Really? This is... Actually, we've seen that the do not disturb mode doesn't work all that well. So if you give me a second, what I'm going to do is just turn the Wi-Fi off because I don't really need it. All right, it's gone. Sorry. Sorry about this. I don't know if Mark is here, Mark Ellison, because he had exactly the same problem in his talk just before. It was pretty funny. So the velocity tracker that we're talking about, how does it work? It's actually pretty simple. You add the movement, and when you receive, let's say, an action up, you compute the velocity, you get it, and then you send it to your flinging method, which is the thing that I was talking about that has a lot of maths. As simple as that. But you don't have to do the maths to know how to scroll. In fact, there's a class in Android that's called a scroller, which is the basis for the real scroll view. It's also the basis for the view pager. It's the basis for the recycler view, the list view. It's a class that is still only a class that will compute stuff and outputs you other stuff. That's very simple. So what you give it is a couple of inputs, and then it would tell you where you should be scrolling, where you should be at any point in time. So the way that it would work, if you got your velocity from a velocity tracker or from a gesture detector, you could just say, all right, fling, here are where you are, here are like the minimum values in X and Y of this view, the maximum values in X and Y of this view, here's your current velocity, just go with it and do whatever you want. So you invalidate the view, and there's a method in all views that's called compute scroll. That's going to happen part of the drawing path. And every time you get there, you just ask your scroller, do I still have to scroll? And if it says yes, it will give you your current position. So you only have to scroll there. And like before, scroll to is a method that is implemented all views, so you don't have to do more than this. And then you have to remember just to invalidate the view so that the view will be implemented correctly. So that's it for scrolling. Let's talk a little bit about drawing. In fact, it's a bit of a crutch. It's not really that important, the drawing itself, but it can give us a very important concept that's very cool. So let's really talk about some simple drawing. You have a view, every time you put your finger somewhere, you take the get X, the get Y, you add it to a path, you draw it to the screen. Not really that important. But the interesting concept behind this is that you're only doing this, you won't really have a smooth curve. The thing that's going to happen is if your app is lagging a little bit, you'll have some sort of jaggy edges. It won't work as you would expect. And why is that? The reason actually is pretty simple. It's that your digitizer translates your touch into motion events faster than your refresh rate. In fact, everything happens on the main thread when you handle touch, just like your drawing commands. So if you're lagging because let's say you have a garbage collection, you might lose some information, because if you spend 100 milliseconds without handling touch and you always use the latest get X, get Y, well, you might have a delta of 100 milliseconds where you don't have information, so the app won't have any other choice than put you a big straight line. But the thing is, there is information to make sure that you don't encounter this problem. And it's solved by what's called batching. And batching is pretty much the whole history of motion events that happen between two calls to your untouched event method. So depending on your case, it might be useful. For example, in a scroll view, it's not useful because you only care about the latest event. But in case of a drawing, or in case of a very complex gesture that has curves, or like recognizing letters, stuff like this, you really have to make sure that you don't lose any motion events. So the way it's going to work is you're going to have a method that's called get history size. So you could have 0, you could have 10 events in there, and then you can get the historical X and Y. So you can get all the values for everything that happened between 2 frames. So how does this look like in action? Well, you have your action move, you have your history size, you can iterate through it, you have all of your history, and then at the end, you can just put the last one that is get X and get Y. It's as simple as that. And now let's talk a little bit about multi-touch. So multi-touch can be a little bit daunting if you never used it, but actually it's very simple. You just have to remember a couple of things. First of all, multi-touch is, of course, putting more than one finger on your screen. Android doesn't know about finger. There's no fingers in the API. What they call those are pointers. So think of a mouse pointer. As many of you want on a screen, that's called a pointer. Android also, of course, doesn't know it's your index finger, your ring finger, whatever, but it can track individual finger easily. So what it's going to do is assign an ID from 0 to N, just to try to find which finger it is so you can reuse them throughout your gesture. You might think also that you're going to receive multiple motion events. In fact, no. Every time you receive a motion event, you have the information for all the fingers or pointers that are on the screen. So the gesture also works the same. It's still the same guarantee as before. You still start with an action down, you end with an action up. But you are still going to receive distinct event just to tell you at least that you added or removed a finger, a pointer from the screen. So every time you add a finger, you receive a pointer down with the ID of this new finger on the screen. And every time you lift your finger, there will be an action, a pointer up that will happen. So at least the principle of touch targets, everything still works, the gesture still works, action down, any number of moves, action, pointer down or up, and finish with an up. So the only two new action, pointer down and pointer up. The thing to know though, and the thing that might be a little bit harder to grasp at first, is that there are two concepts that are a bit clashing when you are trying to work with multi-touch, with multiple fingers. It's the concept of having the pointer index and the pointer ID. And you have to look at the dog to know which int ID it does take. The principle is actually pretty easy. Android will try to be as efficient as possible, and it will pack all the touch events inside of a simple array. You will have an index of this array with all the pointers that you're supposed to have, and each pointer will have its own ID. So if I was to put like my first finger on the phone, it would have an ID of 0, and it would be at index 0. So everything works at 0, that's perfect. I put a second finger, it's ID 1, it's index 1, still works perfectly. I put my third finger, in pointer ID 2, index 2, still works. But the place where it might change, if I remove the second finger that I put on the screen, what's going to happen? It's that Android will compact the array, so my finger number with pointer ID 2 will enter the second index. So you might encounter subtle bugs if you really don't care about the index and you only use your pointer IDs, because it might work most of the time, but when you put 3 fingers on the screen, you remove the middle one, it might crash. So let's see this in action. We're going to try to do something very simple, because multi-touch gesture can become complicated really quickly, like in the hundreds of lines. So let's do something super simple. What we're going to do is take 2 fingers, put them on the screen, and just try to draw something in the middle of the 2 fingers. So the first thing we're going to want to do is, when we receive our action down, it will be our first pointer that will be on the screen, so our first finger. So we'll just keep its ID. When we're going to receive the second finger, it will be an action pointer down, and it will contain the ID of the new finger that was put on the screen. And when we try to move the finger, when we move our fingers, what's going to happen is that we're just going to take those ID, try to find the index in the array of motion events that we receive for this particular event, and then calculate where the view should be. So it usually is the middle ground, is the middle of the 2 events. So the distance in x, distance in y divided by 2. And it's actually not more complicated than that. But multi-touch can become very hard very quickly, and usually you don't really have to handle it yourself, because the usual cases are already coded for you. So the class that you come to learn and love in most of your multi-touch experience is called the gesture detector. So yet again, it's still a math engine. What's going to happen is that you'll just instantiate a gesture detector. You pass it every motion event that you receive, and then you'll have callbacks when interesting stuff happens, like a fling, a swipe, a tap, a double tap, stuff like this. The way it would work, you instantiate it, just pass it every touch event that you receive, and your listener will have all the interesting callbacks. So you don't really have to handle the action pointer down, the action down, the action up. Actually, this will get you most of the way. And even the example that I did first can be done really easily with another gesture detector. So there's a scale gesture detector in the SDK, and there's also one in the support library, which will give you a lot of stuff for free. Because scaling can be quite hard to do, so it gives you something very simple, which you just get a scale factor and handles for you the pinch to zoom, and also the double tap, hold, and zoom that was introduced later. So here are a couple more things that we can talk about. we can talk a little bit about how the motion events are dispatched in the hierarchy. We saw already the unintercept and the untouch events. Well, we can go a bit further. We can start from the activity. In fact, if you take a look at the code of activity, there's a method that's called untouch event. So one common mistake that people could make would say, hey, there's an untouch event method inside of my activity, so that probably means that I can intercept everything that's going through my activity. While in fact, this couldn't be further from the truth. What's happening in reality is that the untouch event method of the activity is the last one to be called in case that nobody was able to become the touch target, in case nobody was able to handle this gesture. So what the real flow is that inside of the activity you'll have a method that's called dispatch touch event. Will receive the first touch event. It will send it to this ruled view, which will also have a method that's called dispatch touch event. It will then ask itself, can I intercept it, by calling its own unintercept touch event. It will then dispatch it to a view if needed, which will call also a dispatch touch event, which will in turn try to handle it. And if it can, it will become the touch target. If not, pass it back to the parent. If the parent can, well, it becomes the target. If not, sends it back to the activity. So in fact, if you want to override everything that's going through your activity, you should probably try to override dispatch touch event. But it's not really a common problem. Another thing that you might encounter in your design is that sometimes you have a view that's a bit too small. It's a bit too small to be touched comfortably. You can click it really, but kind of design asks you to have something a bit smaller. The thing that you can do to make sure that your app is usable is try to increase the surface area of this touchable item, just so that you can make sure that even though, let's say it's 20 by 20 dp, it has at least 48 by 48 dp that are available so that you can click it. And you can do this pretty easily on Android with something that's called the touch delegate. So touch delegate, pretty much what it does is you set it on the parent of the child, and you'll say if you receive a touch in this area around the child, just dispatch the touch event to the child. The way it would work would be if you wait until everything is layouted, you calculate the hit track of your current button. You just, in this case, it's just hard-coded values, but you give it the real dimensions that you want your buttons to have for the touch. And then, as long as your parent's a view group, what you can do is take the view group, set the touch delegate with the new region that you want to dispatch to your child, and voila, it's super simple. Now your button is clickable more easily. Another thing that you might encounter in the SDK is a class called onGeneric motion event. And this class is for all the non-touch based inputs that you might receive, which in fact there are not that much, but some of them could be interesting. For example, if you plug a mouse in your phone, that's a thing that's doable. You will really have a mouse pointer in your app, even on a phone. And what's going to happen is that most of the mouse thing like moving or clicking will work with the touch event system, but there are other states that you can implement, like hovering, like the good old rollovers in web and in Flash. You couldn't do this, there are selectors for this, but let's say a motion event with a hover would go to the generic motion event. Same thing for joystick events. And one last thing that could be interesting is the concept of splitting touch events. It's something that you don't really have to think about it, but what's happening when you put your fingers at two places at the same time on the screen? It's not the same view. Let's say you have two scroll views and you're scrolling both at the same time. Well, scroll views don't have to think about each other. They won't receive action pointer downs. You're not inside of a multi-touch gesture because you're touching two different views at the same time. So what Android is going to do is going to split the streams and start two gestures at the same time. And you get this for free. You don't have to think about it. But in some corner cases, you might want to disable it. If you want to disable it just to make sure that a parent doesn't allow splitting touch event, because let's say you have a layout with a bunch of radio buttons and you only want one to be touched at the same time, you want one to touch two at the same time or touch two buttons at the same time. On the layout, you can always disable splitting the motion events, and it will work perfectly. And actually, that brings us to the end of this presentation. I hope you enjoyed it, and I'm open for questions if you have any. Thank you. Yes?
Super obvious question. Where can I find your deck?
The question is, where can I find my slide deck? I'm gonna post it. The thing is, there are a bunch of videos, and videos are not that friendly with SlideShare and stuff like this, but I'm gonna post it anyway, and it will be uploaded on the YouTube channel of Droidcon sometimes. Thank you. Yep. I'm sorry, I didn't quite catch that. You said about the touch delegate. What's your question exactly? Yeah, so the question is, instead of adding a touch delegate, can you just increase the size of the view? Yes. If it works in your design, that's usually a way simpler way to handle it. Because also another problem with touch delegates is that your parent can only have one. So if there are many views in the same parent, that might not be the best idea. Or unless you have to implement some dispatching code, which is not really fun to do. So usually just increasing the size of your view is a better idea, yeah. So the question is, inside of the web view, there are ways to zoom, like by double tapping. In other places, is triple tapping. So are there ways to, like, detect this and disable this? The short answer is not really. You can go the harder way and just try to intercept all touch events and try to detect if something's weird is happening for your use case, and then you can just stop sending touch event there. Like, you intercept it and you don't accept the gesture. But to be fully honest, I'm not exactly sure, but we could talk about it a bit later and just brainstorm it. Any other question? Well, that's it. Thank you very much for your time.